Hello friends, this is Fani Renders, and today I'm going to show you a bit about Azure Service Fabric. It is a platform for building microservices on Azure, and it's quite cool because you can build all types of microservices, stateless or stateful, or now even recently added is the ability to build microservices using ASP.NET Core. So in this demo, I'm going to show you a bit about what Service Fabric is, how to build a service cluster, and then using the SDK, I'm going to show you how to integrate that with ASP.NET Core to get you going, writing microservices using ASP.NET Core as a framework. Now, the first thing you would know is I'm not an expert in this. I've just recently decided in digging into the bits a few weeks ago. So if there's any concerns or any comments or any questions, please feel free to reach out in the comments below this video. So now the first thing you would need is Visual Studio. You can go to visualstudio.com and get a free copy of Visual Studio. It's called Visual Studio Community Edition. It's free, it's fully functional, it's fully featured, and it is free for use for open source projects and for small teams. If you do have MSDN credits, you can go ahead and purchase it with your credits. You can also go download the enterprise version at visualstudio.com. I've already done that. The next thing you would need, if it's not included, is the Azure SDK. Now, it's the SDK for numerous types of software. For this, we would need the Visual Studio Service Fabric Visual Studio SDK. You can get that by going to azure.com and going to the resources section. Here we'll find the SDKs for Service Fabric SDK and tools for Visual Studio 2015. I've downloaded it and installed it. Now, to get you started, first of all, I'm going to quickly show you how to create a quick Service Fabric cluster in Azure first. You could do this from Visual Studio, but it's just quicker and nicer doing it from the portal. Now, from the portal I am now at, one can click New, and instead of like scrolling through all these other things, you can just type Service Fabric, and it'll pop up Service Fabric Cluster, and you can just basically follow along the steps. Click Create. The first thing we need to do is to give some basic information on this cluster. So I'm just going to say this is a test cluster. It's probably not available. This is test cluster 1 or test cluster Fani, and then give a username, and you will give it a password. Now this is to log into your virtual machine later on if you do need to. You can assign it to a resource group. I'm just going to assign it to a sandbox user group, resource group I have, and click OK. The next thing we need is the cluster configuration. Now here we can specify the node type count. How many types of node do we want? We just leave the default at 1. And the first node type, we can give it a name. We can say my primary node. You can basically give you any node type name. That doesn't like that one, so let's just type Fani type. If I can just type, pardon the pun. And you can choose a durability tier. I'm not entirely sure what this is. Apparently it's a SKU size for a node type. So bronze supports the standard A, D, DS SKUs, and gold tier supports G5. So it's obviously for performance reasons. Now you can select your virtual machine size. For just simplicity purposes, we will just go ahead and choose the default one, which is the standard one there. And then the tier size, or the reliability tier. So this is actually a tier that will determine the initial VM capacity assigned to your cluster. So each tier has a minimum required capacity. There it says platinum 9, gold 7, 5 is silver, and bronze is 3. So we'll just go with bronze for now. You can also set your initial VM scale capacity. You can just use set that as default 5. and you can go ahead and configure the advanced settings. Now this is a very important step, because for my demo I've chosen to do this to expose port 80 for my service. So here you have to explicitly define port 80 as a external endpoint to reach. Furthermore, click OK. Then we go to the diagnostics section. I don't want any diagnostics on this, and then I can click OK because there's no further settings to do. The third step is to do the security. I haven't done this before, so I'll just go onto the unsecure section, or unsecure mode rather, and click OK. And the last step is have a summary that will basically validate all information, making sure everything is fine. And when you hit create, it does take a while to fire up this cluster, so just go have a cup of coffee or beer or something, come back, and it will be up and running in a bit. So I've done that already. I have got a cluster running just to show you how it works. Actually, I'm going to go to my resources. There I've got Farney test already set up. Now, first thing to remember is that this cluster is running virtual machines at the background. So it's got 5 nodes fired up. Here you can see the essential information. It's in a resource group sandbox. It's ready. There's the client endpoint. There's the node count, the application count that's been deployed to it is 1. And then there's something called the Service Fabric Explorer. So if you go to the Service Fabric Explorer, it opens up like a little dashboard specifically to your cluster to show you exactly what's happening on your cluster at the moment. So here we can see all the applications that's deployed to it. Currently I've got one application called application 1. I can also browse all the nodes with specific IP addresses ranging from 10.0.0.4 to 10.0.0.8, and I can see my health is automatically visible to me as OK. And then there are also these system application, which includes a few system services. Now this is the infrastructure part of the microservices platform one would need. So there's a cluster manager service, there's a failover manager service, an image store service, a naming service, an upgrade service. Each one of those have its own job into making sure your service is reliable. When upgrades happen, then it can happen seamlessly, rollbacks can be handled, etc. So do feel free to poke around here and see what is how this works. So all these services are also stateful, I see. Okay, in applications I've got my application 1 type. There are a few versions I've deployed already. Started at version 3.0.23. I'm now sitting on version 26. You can also always roll back and roll forward a version or not. And then in each application type, there's the actual instance of the application. When you drill down, there's the actual microservice of the application, that one specific one. And you can drill down all the way to its to actually get to its endpoint, which is there's its instance and there's its endpoint. So I cannot go to 10.0.0.4 because it's internal address, but because I've exposed port 80, I can basically go to my URL, which is farneytest.westerneurope.cloudapp.azure.com. Put that in there, and I've got an API running there called the color API. So I'll get to that in a second. So when I go there, it will give me a color code. So that's my little API running on port 80. Now let's quickly switch over to Visual Studio to show you how you actually create a Service Fabric cluster from Visual Studio and then deploy it to Azure. So I've got Visual Studio open. And do take note that you need to do this in administrator mode because it needs to do lower level stuff. From File New, you say File New Project, and when the New Project dialog opens up, you can go all the way down to Cloud, and when you install the SDK, you would see there's a Service Fabric application template now available. So we'll just call this test for now. And when we click OK, we can see there's a few templates that we can use. Number one, the stateless template for creating stateless services. There's stateful services. There's the services using the actor model. There's a stateless web API. There's even something called a guest executable. Now that's actually very cool. If you have something like a Node.js or Java or native exe application that does something, inputs and outputs, like specifically like a Node.js service that you want to be able to use as a microservice, one could do that just by following the instructions, and it will actually copy the bits or link it to the bits, and it will relay the calls to your external guest executable, making it actually very robust, I would say. For this example, we would use the ASP.NET Core. This is basically your normal ASP.NET Core template that they give you out of the box, with a few of Service Fabric configuration and startup logic into it. I basically went in here and clicked OK, and it created the application for me. Now I'm not going to actually go through this and have it create the whole thing. I've already prepared an application. Let's click there. So I've already prepared an application on Visual Studio earlier. The layout of it is actually very interesting because it gives you a sort of a umbrella project, which includes all the manifest and settings and configuration. And then you'll have all your microservices, if you will, that's listed below. So here I have only one. It's called Web3. It's a ASP.NET Core application, but you can have many. You can have like guest executables. You can have stateless services. You can have more than one ASP.NET Web API even service. The world's your oyster here, so you can add as many microservices as you want in this solution. The key bit is that on the specific template of the ASP.NET Core, you would see that there are the normal controllers. In this case, I've got my color controller. When I go to /API/color, it will just give me a color back. I think that is blue, if I'm not mistaken. And one of the other things is there's this folder called package root. Within there's a config, where you can do like configuration stuff, and then there's something called the service manifest. Now here you define your endpoints for your service. Now this needs to match the endpoints you expose on Azure. So here I have a protocol HTTP I defined. I give it a name. It's a input type, and I want to expose this service on port 80. That's about it. Further than this, I haven't really dig deeper. Then you have your default stuff, like your startup class, which will initialize your startup class will initialize a configuration builder. It will set a something configuration in app settings, add some environmental variables, and then it will just work because it's the normal stock standard template. In this case, I've added CORS, cross-origin resource sharing, because I'm actually connecting from my local host to a different domain, a different backend rather. Otherwise, this wouldn't work properly. So I'm actually adding CORS to my ASP.NET Core service. One thing to do note as well, so the special bits here is on the program.cs, where everything actually is happening, because this is actually a standalone application, a exe, if you will. It needs a entry point, so it's a public static void main. So here we actually initialize the service runtime, and we give it the type. So here I just say web3 type, and when it starts up, I give it a lambda that initialize a web hosting service, and I just wait for it to finish. Now this web hosting service is actually a stateless service, and it implements iCommunication listener. Now the iCommunication listener has a implementation of open async. So when it opens up, I ask the runtime to give me a endpoint using my endpoint name, and here I just construct a server URL using the context, because Service Fabric needs to give me the context to work with at that given point, and then also the port that is assigned. And here I just use a web host builder to use Kestrel as my server, add content route as my current directory. I use my startup class for configuration purposes. I add my server URL, I build it, and I start it, and Bob's your uncle. Nothing more, nothing less, and this is out of the box, and actually it just works. Now the key thing to remember when you run this, quickly going back to the main umbrella project, there are numerous parameters here. So if you go to your application parameters, you will see there's a cloud and a local one. So testing locally, it's fine. All your instances will be listed here. In this case, I only have one. It's called Web3 instance count. But there is also a cloud configuration where I have a -1 instance count. Because this is the cloud, you can actually have more than one instance. So I would leave that as -1. You could explicitly set it as something like 5 or 8. But for my example, I've just chose to leave it at -1. Local, you need to leave it at 1, because if it's local and deployed locally, if there's more than one instance, because localhost is one IP address, it will have conflicts trying to set up a additional server when it tries to create another instance. Then you have your publish profiles. The same thing. You have got your cloud publish profile and your local publish profile. It's actually quite interesting because the cloud publish profile has a upgrade deployment configuration. We'll go in depth in that in a sec. And then there's this deploy Fabric application PowerShell script, which is not relevant right now. Great. So we have got everything set up and everything is linked. I do need to say that when you run this, make sure you run it on the context of your umbrella application, because if you run it only on the actual microservice sub application, if you will, it won't work, because it actually needs that Service Fabric runtime to give it an IP address and a port. So you do need to fire up the umbrella application. Now when you do this locally, when you start this, it will create a here at the bottom you'll see it will create a it has something called the Service Fabric local cluster manager. Now this is exactly the same thing that's running in Azure. I can just go right click and say manage local cluster, and it will open up port 19,000 or 19080 port, and it will open the Explorer for my local service here, so that I can actually browse this stuff and work with it. When you run it, it actually will deploy to this cluster, and you can see the stuff happening as it would in Azure itself. So I'm not going to go into that locally. What I'm going to show you is how to actually publish this application that we have now to Azure and have a local client application that I'm going to show you now in a sec. So here's my client application that I have here. It's a simple web-based application. I'm using Angular for this right now, with a few styles, for instance, and then I have a few blocks that's running. It's very, very simple. So what it does, it creates 500 block instances. Each one of those instances I would call update color, and update color, if you look here at the bottom, it will actually go out to my backend API, my microservice endpoint, and it will go and ask it for a color. Now it will return a hex value of a color, and it will set that item of that specific block property as of the actual color it receives back, and that is it. So it will do this of a random interval for each little block and then here in the style, I'll just basically set the background color. So it will give you the effect of all the blocks will be blue, and the idea is when I deploy my application, as it deploys through all the clusters, you would see some of those blocks will actually turn another color, and you can have a seamless upgrade without any downtime, and that's very important. To show this thing in action, let's quickly publish my backend first. First of all, I'm going to go right click publish, and then you would get this this pop-up. I'm going to point it to my connection endpoint, which is finitest.westerneurope.cloudapp.azure.com, port 19,000. And here it's important to choose the right parameters, and also then you can go to manifest versions, if you will, to make sure everything is right here. So the manifest versions I will get back to in a sec to show you how the actual upgrade works. So when you take this checkbox off, it will actually create a new deployment of the application. So we'll go ahead and click publish, and it should go ahead and publish a new fresh version of the application to the instance, or to the cluster rather. When that's done, we can actually go to my while that's busy doing its thing, I can go to my little explorer and see what's happening here. Everything seems to be fine. So it actually deletes all the instances and it creates a fresh copy of all the instances here. So I've got 0 applications here now, and in a sec we'll see we'll have 1 application deployed when it's done. Like this, like this. So now it's registering application type, and in a sec it will register the application and everything should be fine. Okay, so let's see if I can get this a bit smaller. Okay, now I've got my little local application now set up that will point out to my backend. Running this, I'm just basically running a simple node server. It's called HTTP server. I'm not going to go into depth how to do this. You just go npm install HTTP server. It's a lightweight HTTP server. And once installed, I can just call HTTP server to actually serve up my local directory on their localhost port 8080. To be sure everything is fine, I will open the incognito window, or in private window if you're using IE. And if I browse to port 8080, you would see a few blocks that I was talking about. So each one of these blocks represents an instance or a connection to my backend. And each one of these blocks has a random polling to my backend asking it for a new color. You can check this out when I go, or not there, when I actually go onto Chrome's developer tools. It's actually giving insufficient resources, but okay, let's just see it. Hope it works. It's actually doing a lot of requests. Great, so now let's see what will happen if I upgrade my application. Going back to Visual Studio quickly. Let's go and upgrade my my color controller, and let's call it a different color, for instance. So when you call this, I want to be able to have this as a different color. Then I literally go right click and go publish. And the next thing I need to remember, instead of creating a new fresh copy, I'm going to click upgrade the application. Now this will allow it to gracefully go through all the nodes and upgrade it one by one, and a load balancer will make sure that the new traffic coming in will be divided to the other nodes applicable. It's important to set the new version. In this case I'm going to go version 27, save and hit publish. And as it's published, you will see in a sec, it says upgrade in progress on the left hand side. Copying application package to image store. Registering application type. And in a sec, you will see here, upgrade in progress going 1. So if we click on this upgrade, you can actually go to the actual deployments and you will see all these nodes being upgraded. Now going back to my front end, you will see all these blocks, and as we continue to upgrade this application, I'm going to talk you through it. You would see these blocks will start to change color as we move on. So first it's now upgrading the first node, node 0, from version 26 to version 27. Everything is still blue, which means it obviously goes through the other 4 nodes. So we can see now the first node has been completed. It's green, so that means it's been upgraded. Now it's busy with node number 1, which is the second node in the line. You could go to the nodes drop down, and as you can see, yeah, it's starting to upgrade it from blue to green. So some of the requests gets routed now to node 0, which is the new version, and the other requests gets routed to the node 2, 3, and 4. To actually manage your nodes, you can actually expand nodes in the left hand side and see explicitly what's going on per node as this thing is upgrading. You can even per node wipe the data, reset the data, etc. Now, as we can see, as the upgrade is progressing through all these nodes, we can see our clients or our blocks are getting a new version, each one of them. As they poll the new version, each one of them gets the new version. And eventually, the whole block will be green, which means everyone will have the same version going forward. Now, the idea with this is you can deploy your microservices without any downtime, or the minimal downtime, depending on your configuration. Now this is actually very, very powerful because, you know, in the world we're living today, we don't need to have downtime because we need to go and be available most of the time to meet the customer's demand. In this case, Service Fabric actually allows you to have a platform of building microservices with a proper infrastructure, because they actually give you all the cool infrastructure built in. And as we can see, it is almost there. It's upgrading the second last node. There should be more green blocks than there are blue, which is the case. And when it's done with the second last one, you will see it will actually be mostly green, because the last one is the newest version, and it's basically offline going to the new version of the service. So I hope you actually enjoyed this demo. Like I said, please do comment on the video below, just here. And if you have any feedback, questions, please you can actually hit me up on Twitter at @FarNetRenders. You can check out my blog at renders.co. And yes, and please feel free to contact me for any feedback whatsoever. Hope you enjoyed this one, and let's just see if everything is fine here. And in a sec it will actually go green, and there we go. Everything is starting to go green, and now my whole infrastructure has a green service, which is the new service. Now I forgot to add that if something might happen and something halfway through, let's say node 2, there's something happens, it needs to roll back, Service Fabric will, depending on your configuration, yet again, it will manage that rollback deployment back to the previous version, and you'll have a seamless rollback. The same way as you upgrade, you will have a seamless downgrade as well. Guys, my name is FarNetRenders. Thank you so much for watching this video, and do take care. Cheers.